Welcome pre-cal students to class today on this Tuesday the 22nd. Hope you guys are doing well. Hope you're ready to learn some math today. First of all, you'll have a test on Monday, so make sure that you are ready for that. If you're not going to be here on Monday, please let me know no later than Sunday. And then also stay on top of your integrity sheets. Whatever you do not have done when you get to my house on Monday, you cannot make that up later for credit. And so please make sure you are staying on top of your integrity sheets. Here we go. Well, men, let's go ahead and finish up chapter 3 today. So we are going to finish chapter 3. We're doing well. We're moving right along. We're going to be looking at different types of variation and also applying them in word problems. The different types of variation we will be looking at today are just different types of equations. Okay, let me say that again. The different types of variation we will be looking at today are really just different types of equations, so don't be concerned about this. It's pretty simple. Let's take our time and look at each type of variation that we're going to cover today. Your heading today is direct, inverse, and combined variations. So we are looking at 3 different types of variations today: direct, inverse, and combined variations. Lesson 3.6. If you want to write the date down today, the date is the 22nd. All right, the 22nd. Lesson 3.6. If you want to turn your books, you're welcome to do that. You do not need to do that, but if you want to, you can, and you will see this box right here. It gives you a definition of what direct variation is. Okay, this box here of direct variation is a definition on page 330. It's not really easy to understand, and I will put this in easier words to understand in a minute here, but it says if you have a situation in which a linear function f of x equals kx or y equals kx, where k is a positive constant, we say that we have direct variation. Another way you can say that is y varies directly as x, or another way to say that is y is directly proportional to x. The number k right here, this number right here in front of x, is called the variation constant or constant of proportionality. Okay, and so let me put that in words you'll understand. Here we go. Maybe you'll want to write this down. In other words, when a simplified equation looks like this, you have y, then an equal sign, then a coefficient, and then an x to the 1 power, in other words, a linear equation. You have direct variation. Okay, so it looks like this. This would not be direct variation. Y equals 2/5 x plus 3. That would not be direct variation. Direct variation has a y, then an equal sign, then a coefficient, and then an x. And we call this direct variation, or y varies directly as x, or y is directly proportional to x. We use all of those phrases. That's easy, guys. Here it is. If the equation looks like this, you have direct variation, or y varying directly as x, or y is directly proportional to x. And this 2/5 right here has 2 names. It has to be positive, first of all, so this number here in front of the x cannot be negative. If it's negative, you do not have direct variation. And then also this number in front of the x is called your variation constant, or it's also called the constant of proportionality. Okay, so this number here has 2 names. Let's go ahead and turn your books to page 331, or you can just follow along here on the screen if you would like to. And let's try a couple examples here of direct variation. Now watch carefully what we do. Find the variation constant and an equation of variation in which y varies directly as x. So we're told right here that we have direct variation, so we know right away we're going to use this model. Let me say that again. We see here that we have direct variation, so we use this model here, y equals kx. And what they tell us is we have y equals 32 when x equals 2. So what I can do is using this model right here for direct variation, where the y is, I'm going to substitute 32. Where the k is, I'm going to leave it k. And where the x is, I will substitute 2. Now, do you not see how easy it is to solve for k? Divide this side by 2. Divide this side by 2. 16 equals k. So the problem said, find the variation constant. I did it. K equals 16. And then write the equation of variation. Well, that's easy to do also. So first of all, I found my k. It equals 16. And now to write my variation equation, or my equation of variation, I simply write y equals, and instead of putting k, I'm going to put 16, and then I'll put an x. So this is your variation constant, and this is your equation, your direct variation equation. Guys, it's that easy. Just understand that you're using this model whenever it says we have direct variation. Okay? Let's try another one. Page 331, example number 2. The number of centimeters W of water produced from melting snow, now look what it says, varies directly as S. So we know that we have direct variation. The number of centimeters of snow. Meteorologists have found that 150 centimeters of snow will melt to 16.8 centimeters of water. How many centimeters of water will 200 centimeters of snow melt? Now, let's think this through. First of all, we see right away we have direct variation. Do you see that okay, students? Direct variation. So I know my model is going to be this. Y equals kx. Now, since this is a word problem, I'm not going to use k and x. I'm going to use the variables they give me. The number of centimeters W of water varies directly as S. So I'm going to put a W here. W varies directly with S. So there we go. Now, let's make sure we know what W is. W is the centimeters of water produced from melting snow. And S is the actual number of centimeters of snow. So please don't forget that. So W is the melted amount of water. S is the exact amount of snow. Now look at this sentence. Meteorologists have found, look at this, that 150 centimeters of snow, that's your S, because remember S is how much snow you have. 150 centimeters of snow will melt to this much water, and that's what W is. W is how many centimeters of water you have left over. So now I can very easily find K. Alright, so I'm going to divide both sides by 150. Divide by 150. Divide by 150. These cancel. And K equals 0.112. So students, I found my constant of variation, so now I can write my model like this. W equals, and where the K is, I will put 0.112 S. Now here's why that's helpful. I now have a model in which at any time you can give me how much snow we have, and I can tell you how much melted water you will get, or you can tell me how much melted water we have, and I can tell you how much snow we had before that. And so this is a very helpful model. Now look at the last sentence. How many centimeters of water will 200 centimeters of snow melt? So I have 200 centimeters of snow. So where the S is, I'm going to put 200 centimeters of snow. Okay? And if I type that into my calculator correctly, I will come up with 22.4 centimeters of melted water. So let's quickly review. I noticed in the word problem it says varies directly. So I wrote my direct variation model. Then I realized I was not going to use y or x. So I looked at the word problem and I realized I had to use w and s. And then I made sure that I knew what w stood for. I made sure that I knew what s stood for. I made the proper substitutions. I solved for k, and then I finished the word problem. Not too difficult. Okay, so that is one type of variation, direct variation. Now let's take a look at inverse variation. Inverse variation. You do not need to turn in your book to page 333. You can if you want to, and that's where you'll find this. I'm going to quickly read it, but I will put it in easier words to understand right here in just a second. If a situation gives a function y equals k over x, where k is a positive constant, we say that we have inverse variation, or another way to say that is y varies inversely as x, or another way to say that is y is inversely proportional to x. The k is called exactly what it was called before, Caleb and Matthew. It was called the variation constant, or the constant of proportionality. Okay? Let me put that in words a little easier to understand. In other words, when a simplified equation looks like y equals 2 over x, in other words, you have a y, then an equal sign, then a number in the top of your fraction, and then an x in the bottom of your fraction, you have inverse variation, or y varies inversely as x, or y is inversely proportional to x. Now, like I've mentioned to you before, that number 2 in the top of your fraction, it has to be positive, and you can call it your variation of constant or your constant of proportionality. Any of those will be fine. Okay? So with that in mind, let's look at a couple problems. Here we go. Okay, you can turn in your books or you can just follow along. Find the variation constant, and look at this, students, watch carefully, and an equation of variation, in which y varies inversely. As soon as you see that, you realize you do not have direct variation. Of course, if we had direct variation, we would use this model right here like we just learned, but we have an inverse relationship. It varies inversely. So we're going to use this model right here like I just showed you. Y equals k over x. And when y equals 16, x is 0.3. So where the y is, I am going to substitute 16. Where the x is, I am going to substitute 0.3. Now, I'm going to multiply the entire equation by my denominator, 0.3, to get rid of my fraction. When you take 0.3 times 16, you will get 4.8, and when you take 0.3 times k over 0.3, your 0.3s will cancel, leaving you with k. So there, you did it. You found your variation constant. And now they want you to write the equation, the inverse equation. So you would simply write y equals, and where the k usually goes, you will put 4.8 over x. So there, we did it. We found our constant of variation, and we found our inverse equation. Not too difficult. Now let's apply that to a word problem, okay? The time required to do a job, look at this, varies inversely as the number of people, P, who work on the job. Okay, so let's stop right there. We know we're using our model y equals k over x. And we know it says the time t varies inversely as the number of people p. So t goes where the y is. T varies inversely with the number of people p. There we go. Now, let's see if we can solve for k. Okay, guys, I'm back. We're going to solve for k. Now, let's see here. Look what they tell us right here. It takes 72 hours, so where my t is, I'm going to substitute 72. It takes 72 hours for 9 people to frame a house. So where the p is, I will put a 9. Now, it should be very easy to solve for k. I'm just going to multiply the entire equation by 9 over 1 to get rid of my fraction. Now, if I do that correctly, 9 times 72 is going to give me 648. And 9 over 1 times k over 9, your 9's cancel, leaving you with k. So look, I found my constant of variation. So now my model looks like this. T equals, and instead of putting a k right here, I'm going to put 648 all over p. And now I have a really helpful model. You can tell me how many hours of work you need to be done, and I can tell you how many people you need. Or you can tell me how many people you have, and I will tell you how many hours of work you'll get done. Okay? So it's a really helpful model. Now look at the last part of the problem. How long will it take 12 people to complete the job? So where p is, I'm going to put a 12. So t equals 648 divided by 12, which will give you 54. So now you know it will take you 54 hours to finish the job. So if your guys are working 8-hour days, it's going to take them 6 to 7 days to get the job done. Okay? All right, let's continue on. So we've looked so far at direct variation and inverse relation, okay? Now let's look at one more type of variation, and we call this combined variation. I'm not going to give you a definition. I'm going to appeal to your common sense, and I'm going to remind you that whenever you hear the word direct variation, you know that means k is being multiplied by x. And whenever you hear the phrase inverse variation, you know that that means k is being divided by x, which is what we just looked at in the past two types of variation. All right, so with that in mind, let's go ahead and get started. In these next 4 problems that we're going to solve, you're going to see that they're going to throw all kinds of curveballs at you. They're going to combine direct and inverse variation within the same problem. They're going to give you squared numbers, all kinds of things, and that's fine. So here we go. Find an equation of variation in which y varies directly as, now notice it doesn't say x, it says the square of x. So we're going to write an equation in which y varies directly as the square of x. So y varies directly with the square of x. And they give us a little help here. Y equals 12 and x equals 2. Now please understand, guys, you cannot write the equation that they're asking you to write until you first find k. Once you find k, it's very easy to write the equation, but you must find k first. And so that is why we are making this substitution. So I really have now 12 equals 4k. 2 times 2 is 4. And now divide both sides by 4 and you get this. 3 equals k. So now we take this equation right here, and where the k is, we're now going to get rid of the k, and in place of the k, we're going to put 3, because that's what 3 equals. And there, now you have written an equation in which y varies directly as the square of x. And by the way, you could check this. Where the x is, you could put a 2, and where the y is, you can put a 12, and you should get out a true statement. Okay? Take some good notes on this. Let's continue on. All right, number 6. Find an equation of variation. Now here's a new phrase you've never heard of, so listen carefully. In which y varies jointly as x and z. Now I've never taught you this, so listen carefully. Whenever you see joint variation or y varies jointly, it is assumed that you have direct variation. And not only is that assumed, you're going to have more than one variable on the right side. Let me show you what I mean. Y varies jointly as not only x, but also z. So it would simply be this. It's so easy. It's y equals k, then x, then z. Or you could put y equals k, and then z, and then x. They're all being multiplied. It doesn't matter. Now you're used to seeing y equals kx, and the reason we're throwing a z in there is it says y varies jointly as not only x, but also z. And so that's why the z has to be put in there. And now let's go ahead and write the equation. Y is 42. They give that to you. X is 2. Z is 3. So next you would have 6k. 2 times 3 is 6. And now divide both sides by 6, and you realize your constant of variation, or your variation constant, equals 7. So now you take this equation here, and where the k is, you're going to put a 7. And there, you did it. Just that simple. Find an equation of variation in which y varies jointly as x and z. And there it is. We did it. Okay, 2 more problems. Find an equation of variation in which y varies jointly as x and z. Okay, let's stop there. So y varies jointly as x and z, and inversely as the square of w. So that means inversely means w is going to go in the bottom, and it's going to be squared. Now I hope that makes sense. Let's look at it again. We have y varies jointly, that means direct variation, as x and z. So k varies directly with x and z, and inversely, so we know w is going to go in the bottom, as the square of w. And now let's go ahead and make our substitutions, and let's solve for k. So y equals 105, x equals 3, z equals 20, and w equals 2. So 2 squared. Now I'm going to skip some steps here and just quickly do all this in my head. I mean, 3 times 20 is 60, 2 times 2 is 4, 60 over 4 would be 15, so I'm left with 15k. 15k. Alright, and now if you divide both sides by 15, you will get 7. 7 equals k. Now we're not done. We have to write the equation. So where the k is, I'm going to put a 7 and I'll be finished. So your answer is y equals 7xz over w squared. Not too bad, guys. Let's take a look at one more problem and we're finished with the video today. And you'll have about, I think, 18, 19, 20 problems of homework tonight, but they go by pretty quickly. All right? Okay, a word problem, a good word problem. Here we go. The volume of wood V in a tree varies jointly. So here we go. The volume V varies jointly, so here's my K, as the height 8, or the height H, and the square of the girth. So the girth squared. And girth is the distance around the tree. If the volume of a redwood tree is 216 meters cubed, so 216, and by the way, that does not mean that you're cubing the 216. The cube just means, remember, area is always square, volume is always cubed measurement. So for V, I'm going to put 216. K will be K. And let's see, the height is 30. And the girth is 1.5. Now let's go ahead and do some simplifying here. On the right side of the equation, if we take 1.5 and square it and multiply it by 30 right here, we're going to get 67.5. So on the right side, we now have 67.5 K. And all of that equals 216. Now, if we divide both sides by 67.5, we will get 3.2. So now we know what K equals. So just like that, I know what K equals. Now I can go up here in my original equation or my original model, and where the K is, I can put 3.2. So V equals 3.2 hg squared. Now let's move on and read the rest of the problem. What is the height, so I'm looking for h, of a tree whose volume is 960 and whose girth is 2? So 3.2 stays 3.2, h is h, and for g I'm going to put 2 and then squared. So this really isn't too difficult. If we're solving for h, if you square 2, you get 4. If you take 4 times 3.2, you will get 12.8 h, and then bring down your 960. And now, if you divide both sides by 12.8, you will get 75 for the height of the tree. And there we go. We solved the problem. So this model right here that I'm circling in red, this model is really helpful. I mean, think about it. I can give you a volume and a height, and you tell me the girth. I can give you the volume and the girth, and you tell me the height. I can give you, or you can give me the height and the girth. I can give you the volume. This is a very helpful model, just simply because you knew what joint variation means. Okay, so there we go. I hope this lesson's been easy to understand today. Again, we've looked at 3 types of variation: direct, inverse, and combined. Here's your homework. Page 336, numbers 1 through 39 odd. Please do your homework well. Use the homework help video to help you if you have any questions. Call me or email if you have any questions. And I hope you guys have a good day today.